Today we will be exploring the Palos Verdes Peninsula. It was created by a tectonic fault block of seafloor sediments that began rising out of the Pacific Ocean about 1.5 million years ago. A block fault is when two large portions of land are sliding against each other. In the case of the Palos Verdes Peninsula, one was pushed up out of the ocean while the other one stayed below sea level. The Palos Verdes Peninsula rises majestically from the flat floor of the Los Angeles Basin, stretching 9 miles by 5 miles and covering approximately 22,000 acres. Here on the trails along the Palos Verdes cliffs, you can see many sedimentary rock layers. The layers that come from below the ocean were created from volcanic activity. These sediments are considered part of the Monterey Formation and were deposited on an eroded terrain of metamorphic rocks during the Miocene period. Sedimentary layers are formed in many different ways, from the movement of the earth itself to the wind blowing sedimentary deposition from the mountains in the north, comprising a vast accumulation of rock, gravel, and silt. Over millions of years, these layers of sediments were deposited on top of one another and over time created the layers that we see in the present day cliffs. The effect the rain has had on the land in the Palos Verdes Peninsula is erosion, which is the physical removal of material by mobile agents such as water, wind, or ice. Although it may sound the same as weathering, it is not, because weathering involves no movement, whereas erosion does. Erosion has affected many parts of the Palos Verdes Peninsula. One site is now known as the Sunken City near Point Fermin. Another site is Portuguese Bend, where the water pipes are sitting above ground instead of below. The instability of the slopes has made the ground slip down the side, causing large portions to fall into the ocean, like this section of Paseo del Mar right here behind me.
As my partner already mentioned, this is the Sunken City, which began sliding in 1929. It lasted up until the mid-1930s, and geologists called it a slump slide, which basically means a landslide that's caused by erosion that ate away at the bottom of the cliffs. And because the tops of the cliffs were already slanted slightly toward the ocean, all gravity had to do was use its force and pull down the mountain, and along went the houses. And all that's left now is basically a bunch of rubble. There's pipes and rocks everywhere, pieces of houses that are being tagged on, and as you can see, there's still houses up top, but down below it's just a reminder of what used to be there. And nowadays, even though there's no trespassing, people still trespass. They do their art. There's people sunbathing, people doing picnics, people doing all kinds of things. There's even people doing class assignments. Now this was just before the Sunken City, and it's called a scarp, which is a steep slope that results from erosion and separates two relatively level areas of differing elevations. The locals called this suicide drop, as you can see why. Up and down the coast near Point Fermin, there are many round and smooth rocks, and the reason for this is because of wave erosion and abrasion. Wave erosion is the constant grinding of the water waves against the rock, and abrasion is the constant grinding of the rock fragments along the rocks as well. So a combination of these two things is the reason why these rocks are so smooth, and they're pretty abundant up and down the coast, as you can see. Now, in my opinion, the most fascinating feature along the coast were these tide pools. And these tide pools are basically holes or crevices, if you will, that based on high tide or low tide, they have life forms separate from the ocean. And some of the key factors that contribute to what actually can live inside these tide pools are temperature, how much light gets into these pools, the characteristics of the bottom of the pool, and the salinity levels, which means how much salt is actually in each pool.